Today we are going to learn about efficiently reading large files in Python. We will explore techniques to manage memory and optimize performance in data processing tasks. In our world of big data, efficiently reading large files is crucial for performance optimization in Python. This video will walk you through essential techniques for handling large datasets effectively. We'll cover memory management, file iterators, buffered reading, and more. By the end, you'll be equipped with practical skills applicable to real-world data processing tasks.
Let's start with an overview of Python's file handling capabilities. Python provides a built-in function called open to handle files. When opening a file, you specify the mode, R for reading, W for writing, and A for appending, among others. Remember, it's crucial to close files after operations to free up system resources. Python's with statement is often used to ensure files are properly closed. This block will lay the foundation for understanding how Python interacts with file systems and prepares us for more advanced techniques.
File iterators are a powerful feature in Python when dealing with large files. Unlike reading an entire file into memory, iterators allow you to process one line at a time, which is much more memory efficient. This method is particularly useful when working with files that are too large to fit into RAM. To use file iterators, simply loop over the file object itself. For example, with open_large_file.text as f, for line in f, process line. This approach minimizes memory usage and maximizes performance, especially in data-intensive applications. Buffered reading is another effective technique for handling large files. Python's I/O module offers a buffered reader class that can significantly improve file reading speed by minimizing the number of I/O operations. Buffered reading involves reading chunks of data into a buffer, reducing the frequency of disk access. To use it, import the I/O module and create a buffered reader object. For instance, with open_large_file.text, RB, as f, buffer equals io.bufferedReaderF. This approach is particularly useful for binary data and offers a noticeable performance boost over unbuffered methods. Chunk reading is a strategic approach for managing large files in Python. Instead of loading an entire file into memory, you can read it in smaller, manageable chunks. This technique is invaluable when dealing with large datasets that exceed available RAM. To implement chunk reading, specify a buffer size when reading the file. For example, with open_large_file.text, RB, as f, while chunk, equals f.read 1024, process chunk. This method allows you to process data incrementally and is highly effective for applications like data streaming and real-time processing.
Generators are a powerful tool in Python for efficient file processing. They allow you to iterate over data without storing it entirely in memory. Generators yield items one at a time, making them ideal for handling large datasets. Unlike iterators, which are objects you can iterate over, generators are functions that produce an iterator. You can create a file generator using the yield keyword. For example, def read_large_file_path, with open file_path, as f, for line in f, yield line. Generators are particularly useful for large-scale data processing tasks where memory efficiency is paramount. Understanding the difference between text and binary file reading is crucial for efficient file handling in Python. Text files are human-readable and typically encoded in a character set like UTF-8, while binary files contain data in byte format. Python offers distinct methods for each, R and W for text files, RB and WB for binary files. Binary reading is faster as it doesn't involve encoding translation. Choose the method based on your file type and processing needs. For instance, use binary reading for images or executables, and text reading for logs or data files. Error handling is a critical aspect of file operations in Python. It ensures your program can gracefully handle unexpected issues like missing files or permission errors. Use try-except blocks to catch exceptions and implement fallback strategies. For example, try open file.text except file not found error, print file not found. Always ensure files are closed properly, even in the event of an error, by using finally blocks or the with statement. Effective error handling prevents data corruption and enhances the robustness of your file processing applications. Let's explore some real-world examples of large file processing in Python. In data science, handling large datasets efficiently is essential for tasks like data cleaning, analysis, and machine learning. Consider a scenario where you need to process a multi-gigabyte CSV file. Using techniques like file iterators, chunk reading, and generators, you can manage memory usage and optimize performance. These methods are applicable across industries, from finance to healthcare, where large data volumes are common. By understanding these techniques, you can tackle complex data processing challenges effectively. We've covered a comprehensive range of techniques for efficiently reading large files in Python. From file iterators and buffered reading to chunk processing and generators, these methods are essential for optimizing performance in data-intensive applications. Efficient file reading is crucial for real-world tasks, and I encourage you to practice these techniques. Explore additional resources to deepen your understanding and apply these skills in your projects. Thank you for joining us in this learning journey, and happy coding!